In this video, we are going to talk about what it means to write a polynomial in standard form, and we're also going to review what it means to combine like terms. So what I want to first do is define what a polynomial is. A polynomial is an expression that contains one or more terms. So in my example here, I have 4x to the second plus 2x minus 3. This is a polynomial that has 1, 2, 3 terms. So there's 3 terms that make this polynomial up. And if I say put your polynomial into what's called standard form, what that means is we want the expression to be in order by the exponents of the variables from biggest to smallest, with the constant term at the end. So here's an expression, negative 4x to the third plus x to the second minus 2x plus 7. That is in standard form because the exponents go in decreasing order. I have x to the third, followed by x to the second, followed by the x term. Remember, that's really x to the first. So you can see it goes 3, 2, 1. That plus 7 at the very end, that's a constant. So remember, constants do not have variables attached to them. So in these examples, all I want to do is take these polynomials and rewrite them so that they're in standard form. So I just want to make sure I order these terms with the biggest exponent first, go in decreasing order, and put the constant at the end. So my first example is negative 5x to the second plus 10 plus x minus x to the fourth. So if I look at my exponents here, I have an x to the second, 10, so that's the constant, plus x, remember that's really x to the first, and I have a minus x to the fourth. Well, the x to the fourth term is my biggest term, but what you have to be careful about here is that when you rewrite it, you really include that minus sign. That goes with the x to the fourth. So my first term is really a negative x to the fourth. My next biggest exponent is x to the second. So I have a minus 5x to the second. There's my next term, a positive x, and that constant plus 10 goes at the very end. All right, so this expression is in standard form because my x to the fourth came first, followed by the next biggest exponent, which was x squared, followed by the next one, which is just x to the first, and my constant at the end. Now number 2 is going to look like some of the problems you might see in Delta Math. So what you want to be careful about is these fractions. Don't let them throw you off. Negative x to the third over 4. That's just a term, but that term is the x to the third term. It really just means negative 1 x to the third over 4 plus 10x to the fifth minus 5. So if I want to order these, I don't really need to worry about that negative 1 over 4, I'm just going to look at the exponents of my variables. My biggest exponent here is the x to the fifth term. So I have a 10x to the fifth first, followed by this term, the minus x to the third over 4, and there's my constant minus 5. So my biggest exponent was 5, the next biggest exponent was 3, I didn't have anything else except the constant. So if you see those fractions in your problems today in Delta Math, don't let them throw you off. You're just ordering it based on the exponents, not those numbers attached, the coefficients. Okay, and if you look at the last example for putting in standard form, I just have a lot more terms here. So just be careful, make sure you scan the problem. All right, I have a negative 9, a 1/8 to the x. There's that other fraction there. Again, don't let it throw you off. Okay, so that's really x to the first there. A negative 7x to the fourth, an x squared, and a negative x to the fifth. Well, this x to the fifth is big, the biggest one, but again, I want to include the minus with it, so it's a negative x to the fifth. Then my x to the fourth term comes next, negative 7x to the fourth, followed by the x to the second term, plus the 1/8 x, and finally my constant, minus 9 at the end. So I have negative x to the fifth, minus 7x to the fourth, plus x to the second, plus 1/8 x, minus 9. So 5, 4, 2, 1, and my constant. All right. So putting something in standard form just means making sure all of your exponents are in order from biggest to smallest. What I want to do now is just a refresher on combining like terms. So we did combining like terms in the beginning of the year. Remember, like terms are terms that have the same variable and the same exponent. So for example, a 7y to the second could be combined with something like a negative 3y to the second. They're both like terms. or an x to the third could be combined with something like a negative 4x to the third. They're also like terms. They each have the same variable and they have the same exponent. Just don't forget when you are combining like terms that you only add or subtract the coefficients, which are the numbers in the front of the variables. You do not add or change anything about the exponents of the variables. So if you're going to add an x to the third with another x to the third, it's going to stay in x to the third. It's the number out front that changes. Okay, so let's look at two examples of combining like terms that you could see in your Delta Math practice. All right, so if I look at number 4, I've got this big expression, and if you remember, something I suggested doing in the beginning of the year when we did this topic was I kind of like to box in or circle or underline the like terms. All right, so if I start with here, I've got a 2, right? That's a constant. I can only add that to any other constant I see. So if I scan through the problem, I have a +7 and a -5. Okay, so I'm going to add 2 plus 7, which is 9, and 9 minus 5 is 4. All right, so I added those three terms together. Now I'm going to scan my problem, and I have a 3x. Now be careful, you want to make sure you include that negative. So I've got a negative 3x. Okay, so I can only combine that with any other x's. There's a positive 7x. There's another x, and again, that has a minus sign with it. And I don't see any other x's. So negative 3 plus 7 is 4, and 4 minus that x, why don't you think of that as like a 1 out front, a -1. So negative 3 plus 7 is 4, and 4 minus 1 is 3. So that becomes a positive 3x. Okay, the last like terms I have, I've got a, let's see, I'll kind of bubble that in to make it look different. I've got a positive 2x to the second and a negative 4x to the second. So 2 minus 4 is a negative 2. Now it was an x to the second. It's going to stay an x to the second. Don't do anything with that. The last thing I want to do is I'm going to put this into standard form. So my x to the second term comes first. So that's a negative 2x to the second plus 3x, and I'll put that constant at the end. Okay. All right. And if I look at my last example here, again, I'm just going to go through and combine all of my like terms. Now, one thing you'll notice here is that number 5, I have some y's, but I also have some x terms. All right. So your answer might have x's and y's in it, which is fine. Just combine the terms that are like terms. So let's see. So here I have a negative y to the third. So I'm going to look for any other y to the thirds. Okay, I have another positive y to the third. If I keep looking, I have a negative 5y to the third. And then I have a negative 2y to the third. Okay, so if I combine those, remember, think of these as like ones out front, your coefficients. Negative 1 plus 1, well, they're going to cancel. So they're gone. So I'm going to add negative 5 plus a negative 2. So that is a negative 7 y to the third. Okay. Then I have a constant here, 4. So the only other constants I can add here, I see a plus 3 and another plus 3. So 4 plus 3 is 7, plus 3 is 10. All right. And my last term here, a positive 7x to the second, that doesn't have any other like terms, so I'm going to bring that down. Okay. So now what you can do is, because we have two variables, standard form isn't really going to matter here. You could type this answer into Delta Math and it would accept it.